The Earth has undergone numerous mass extinctions since the first bacterial life evolved about 3 billion years ago, and we are facing a potential 11th extinction as global warming threatens to disrupt our planet's ecosystems. In this video we count down the 5 biggest Earth mass extinctions. The KT extinction was a global extinction event responsible for eliminating approximately 80% of all species of animals about 66 million years ago. The KT extinction was characterized by the elimination of many lines of animals that were important elements of the Mesozoic era, including nearly all of the dinosaurs and marine invertebrates. Many theories have been offered over the years to explain dinosaur extinction, but only a few have received serious consideration. The extermination of the dinosaurs has been a puzzle to paleontologists, geologists and biologists for 2 centuries. Proposed causes include disease, heat waves, freezing cold spells, the rise of egg-eating mammals and X-rays from a nearby exploding supernova. Since the early 1980s, however, much attention has been focused on the so-called asteroid theory, formulated by American scientists Walter Alvarez and Luis Alvarez. This theory states that a meteorite impact may have triggered the extinction event by ejecting a huge quantity of rock debris into the atmosphere, enshrouding the Earth in darkness for several months or longer. With no sunlight able to penetrate this global dust cloud, photosynthesis ceased, resulting in the death of green plants and the disruption of the food chain. The Ordovician extinction actually comprised 2 separate extinctions, one occurring 447 million years ago and the other 443 million years ago. By the time these 2 pulses were over, the world's population of marine invertebrates, including the brachiopods and corals, had declined by a whopping 60%. The cause of the extinction is still a mystery. Candidates range from a nearby supernova explosion which would have exposed the Earth to fatal gamma rays, to the release of toxic metals from the seafloor. The Cambrian extinction event occurred approximately 488 million years ago. This early extinction event eliminated many marine species and severely reduced the number of trilobite species. The middle of the Cambrian period began with an extinction event. One hypothesis suggests that this was due to temporary depletion of oxygen, caused by an upwelling of colder water from deep ocean areas. The upwelling eventually resulted in a variety of marine environments ranging from the deep ocean to the shallow coastal zones. Scientists theorize that this increase in available ecological niches set the stage for the abrupt radiation in life forms commonly called the Cambrian explosion. The snowball Earth hypothesis proposes that Earth's surface became entirely or nearly entirely frozen at least once, sometime earlier than 650 million years ago. Proponents of this hypothesis argue that it best explains sedimentary deposits regarded as of glacial origin at tropical paleoaltitudes, and other features in geological record. Opponents of this hypothesis contest the implications of the geological evidence for global glaciation, and the feasibility of an ice or slush-covered ocean, and emphasize the difficulty of escaping an all-frozen condition. While the geological evidence for snowball Earth is strong, its cause is hotly disputed. The possible candidates ranging from volcanic eruptions to solar flares to a mysterious fluctuation in Earth's orbit. Assuming it actually happened, snowball Earth may be when life on our planets came closest to complete extinction. A major turning point in the history of life occurred 2.5 billion years ago, when bacteria evolved the ability to photosynthesize. That is, to use sunlight to split carbon dioxide and release energy. Unfortunately, the major byproduct of photosynthesis is oxygen, which was toxic to the anaerobic organisms that appeared on Earth as far back as 3.5 billion years ago. 200 million years after the evolution of photosynthesis, enough oxygen had built up in the atmosphere to render most of the Earth's anaerobic life extinct.